This is a production of Cornell University.
Yeah, thanks everyone for joining. This is week 5, episode 10 of the Cornell Turf Show this year. We're going to have a lawn and landscape episode today with Dr. Doug Soldat, University of Wisconsin-Madison. You loyal listeners and watchers will know Doug from past seasons. We're going to talk about common lawn issues, soil physical properties today will come up. Who knows where we'll go from there, but certainly a common issue we see and one that's maybe difficult to address for homeowners and landscape contractors. So excited for that conversation. Bet as always, Frank, I'll let you start us off maybe with, you've always got an interesting image, a fun image to show us at the start. And of course, weather updates as well. That's a big part of this.
There we go. You got the slides, Carl?
Perfect.
All right, good. Welcome to the program. Thanks, Doug, for joining us. Thank you all, our loyal live listeners, and for those of you listening on the podcast and watching the webinar later, welcome. We're going to be talking soils today, but I thought I'd start out with a really cool picture of a lawn in Arkansas that is in bloom. It looks like a tall fescue lawn that's got these beautiful hyacinths in them and really important for pollinators. The conversation is continuing to grow about this kind of alternative to lawn stuff in the spring.
Hey Frank, can you share your slides? We're still looking at the.
Okay, you're not looking at the slides.
Yeah, try again.
Let's try again. Here we go. Thank you.
Perfect. There we go.
Got me, Carl? So
yeah, there's
now you're looking at the hyacinth lawn.
Yep.
Excellent. Sorry about that. So there we are, lawn alternatives. Oh. But this was the slide for today. I pulled this off of a newspaper article that was writing about this issue. And, these are the kinds of hourly wages that this industry is confronting in heavily urbanized, heavily landscaped areas. And that's probably an issue that's dominating a lot of the conversation in this industry right now, not just in lawn and grounds. This happened to be landscape help, but the golf industries, sports industries are facing the same situation. So Carl, let's do some numbers about lawns and home value for why this is so important to have people to come and labor over it.
Yeah, so we've talked about ecosystem services and what turf grass and lawns can provide from a carbon sequestration, stormwater runoff perspective, but there is some value in just it looking good in your lawn and at your household. And this was a study where they looked at a bunch of housing listings in a certain area, I believe it was Tennessee, and they essentially rated the landscape quality. Was it below average, good, excellent? And they normalized all these housing values for that landscape quality. And they found if you can make your landscape go from average looking to good looking, you'll increase your home value by almost 6%. And furthermore, if you increase it from an average quality landscape to an excellent landscape, you'll increase your home value by 11%. And essentially what they found is for every dollar you invest in your landscape, and this is not turf grass specific, it's about mulched beds and trees as well. But for every dollar you invest in your landscape, you're going to get $1.35 in housing value. So a really interesting way to think about, hey, what's the value of things looking good at your home?
Hey, Carl, can I interrupt quick?
Yeah.
This stuff is cool, but I wonder how they controlled for like the stuff on the inside of the house. Cause I'm thinking about people that have a nice landscape. They usually take good care of the inside of the house. So do they talk about that at all? If somebody's got a really bad landscape, I know that they're probably inside of the house is bad too. And that you have to factor that in the house.
Yeah. I think they looked at the age of the house as a control. And then I think they bracketed by cost ranges. So, 200 to 250,000. I think they were sort of assuming if it was about the same value. They do square footage, I think, was another control variable. It's not perfect, but it was interesting. And this landscape quality metric was actually pretty heavily influenced by trees. And I think they actually found like 60%, if 60% of the home of the lot area was covered by trees, that was the ideal shade percentage. They even mentioned that in there, which is interesting. So if you're overshaded or undershaded, that affected value. So yeah, some really interesting stuff. Is that a hard and fast number? No, and it was one region, so who knows how that translates to places up north, but it's interesting nonetheless to see that general value of, hey, things look better, you get better home value.
I mean, we
pass it
talk
on to you
about
for
this
that.
same thing with like fixing a kitchen or fixing a bathroom or fixing a bedroom,
Yeah.
right? Inside, for every dollar you invest in it, you'd like to think you're getting something out. So I would look at those. I think you're right about that, Doug. You got to be careful what you control for here, but I think there is this cultural norm that this represents in some cases, that people would look at certain traditional landscapes and view them as kept, and like HOAs have guidelines for these things, right? I think a lot of that thinking is based in the cultural norms of the picture in the background here. But yeah, trying to correct for some of the other variables is tricky, but I think this informs a lot of stuff about even, what we're forced to manage. So listen, this is great. We got a lot of curveballs ahead of us together today. I actually poached some of your slides that I'm going to ask you about too. So we're going to have lots of fun doing this. So let's get with the weather. And overall, it was, 2 to 4 degrees above normal last week. So a little bit warmer than normal. We're expecting the 6 to 10 day outlook by the prediction models that we typically look at each time we hold this session are looking clearly below normal, like it's going to be cold again. So, the roller coaster ride that we're on looks like it's heading down now into low temperatures. And how that manifests itself is the growing season doesn't progress. And one of the metrics of watching the growing season progress is how many days is it different from normal, and how many growing degree days, base 50, do we expect to accumulate, right? This is a good measure of how much does a growing season compare to normal, and how is it going to be progressing moving forward. And so one of the things we're seeing is that we're right around normal through most of the northeastern regions, maybe even a little bit ahead along the coastline. As you get inland and higher elevations, a little bit further behind normal. And then the forecast moving forward is a lot more than it's been, right? We've typically been looking at, single digit and maybe low teen accumulation. And you can see we're starting to get into the 20 to 30 growing degree day accumulation over a 5-day period. So we're going to see some progression of the potential for the turf to grow. This just using a metric for the potential that the system may have to go. Obviously between 50 and 58 degrees, you see a pretty quick increase in the potential for the turf to grow. Now, this is not an ideal or complete measurement of how the grass will grow, but it's an indication of the kind of growth you might expect based on the average temperature likely to increase over the next several weeks. Now, we tend to use phenological indicators in this process. And so we're starting to hear about a little bit of green showing up on the forsythia in the metropolitan New York area. And you look at the GDD tracker, one of the tools in lawn and grounds we use the phenological indicators for is for crabgrass germination. So I like to use another data tool in addition to the phenological indicator, in addition to potential growing degree days, but looking at the growing degree day tracker and seeing where crabgrass might be germinating based on this model set for the metropolitan New York area. You can see even into southern Jersey, we're still a little bit ahead. We might start seeing it in the next couple of weeks, but this is an indication that you still have a little bit of time to get some seed down. If you're using pre-emergent herbicide, to get that pre-emergent herbicide down, because you're still a little bit ahead of germination. The other aspect of weed control we talk about, again, not ideal. We'd rather you did broadleaf weed control in the fall, particularly perennial broadleaf weed control. But if you got a new customer or dandelions are starting to pop, the ester and amine formulations, we have some models that we verified from the old Purdue research that basically says, yeah, you're starting to get into favorable way down in the southern tip of New Jersey in the Atlantic City area. 2-inch soil temperatures are revealing how warm it was last week. and how much the system accelerated. If you remember, we were at 48 degrees at peak 2-inch soil temperature last week. And the models are saying we're well into the mid to upper 50s now throughout the metropolitan New York area. Now, rainfall wise, if you were in the Hudson Valley, Northern Jersey, Orange County, maybe a little bit along the Connecticut, Massachusetts, Vermont, New York borders, you got maybe an inch, 2 to 3 inches. But if you were in the middle of that vein, maybe Poughkeepsie, maybe it looks like, I'm trying to figure out where that is. Yeah, that looks not far from Poughkeepsie. You might have been 4 inches of rain. So that's a real big dump. So looking at that rainfall, now that we're starting to warm up, evapotranspiration is getting a little bit better, right? We're getting a little higher levels of evapotranspiration. We're starting to see things dry out a little bit. So the yield from a rain event is going to start to be reduced, right? Because you're going to lose a little bit. If it comes down really fast, like that 4-inch rain, it's more likely to run off than necessarily get absorbed, okay, depending on the rate at which that fell. So paying attention now to evapotranspiration, it's early days, but I can tell you in the Gulf side, where they've got injured annual bluegrass, they're starting to put some water on it because they're noticing those compromised plants in sand-based soils are a little bit, they do better with a little bit of water up at the surface. Hard to call rainfall, what it's going to be. Looks like there might be a couple of systems moving through. As you get north, it might be more above normal. We're expecting normal precip might be a little bit drier to the south. All right. So I want to start the soil conversation by saying how oftentimes weed populations are related to poor soil conditions. How sometimes good lawns in the spring may have nothing to do with how you fertilize, but has a lot to do with the condition of the soil. In particular, as oftentimes we have Doug, we tend to talk about physical properties of the soil. Doug's seen this picture. I've used it in the past when he was on the show. Here are the kinds of problematic situations you get in urban environments where you've got a focused traffic area, soils prone to compaction. You know, what makes them good to grow in sometimes can make them more prone to compaction. And so we start to think about how do we move water through these compacted situations. And we go back to the old 50s movie of the core filled with straw, water dripping, and the wetting front of the soil as it's impacted by that macropore that the aerification creates. So Doug, some of the discussion today, we've had it before, but I'm pulling in some urban environmental stuff I've seen you talk about, is that first off, that particularly when we talk about lawn and grounds, native soils, it's important to remind folks that sometimes the benefits of these aerification events are fairly short-lived. And so you combine that, I pulled this off of one of the common sort of YouTube lawn stars out there that was promoting the need to aerify a lawn that already looks this friggin' good, right? And is using the traditional drum aerifier. And Doug, I've poached a couple of slides from some of your talks, so these should be familiar to you. Looking at the spacing here on some of these drum rollers can be as much as 5-6 inches. And so this common slide that's used, that you use, that the USGA has about how big is the tine you're poking in the ground, how far apart are they, how much of the actual surface area you impact. And then, of course, this was about how much sand you could incorporate, right? Because it typically is associated with a aerified sand putting green. You can see really clearly, and for those watch or listening on the podcast, I'm circling the largest tine at 5/8 inches. I'm sorry, 5/8 of an inch, and 1 inch by 1 inch spacings affects about 30% of the surface of the turf area. And so looking back, we're a fifth, we're much less than that at a 5-inch spacing. So we have limited amount of area that we impact generally. We have the potential when we don't time the aerification right, Doug, as you've shown in these slides, can then create some challenge around weed seed germination, drought stress, winter desiccation. And you've talked about ameliorating. That's a great word. You must have learned that when you were here, and me and you and Micah were talking about, you know, lugubrious and fancy words like that. How you fix these problems in urban soils through the addition of compost. And then I grabbed some of your blasts from the past here. It's like, okay, the move with a bad soil is to aerify it and put compost. So I'm setting you up here now. You can see on the Buffalo site and the Rochester site, compared to control, the infiltration generally increased as you put different types of manure. Now, I know you've changed some of this work in working with yard waste, but in this slide deck I got my hands on, you had these great pictures of the impact of particularly phosphorus, which is the nutrient of concern, as you indicated in these slides, the nutrient of concern in urban areas that leads to that eutrophication, right? Nitrogen is the issue, maybe more so in an agricultural situation, but in urban areas, pretty good indication in this particular slide, how phosphorus potentially is causing the trouble. Now, again, I want to see where you gave this talk that I poached those things from, because this was really fascinating. You brought in some of our colleague Zach Easton's work when he was studying here. But essentially, when you look at urban runoff, and I know Carl appreciate this, we're talking about this all the time these days, as you get to places where you get more grass, you get a significant reduction in runoff. So Doug, in this presentation, you talked a little bit about this watershed project in Connecticut that I want to set you up for here, and basically start out with this simple question: does routine aeration and compost addition improve soil health and reduce environmental risk? Does the way we want to fix these poor soils in urban conditions reduce environmental risk and fix the soil? So how's that for a setup?
That's great. That's
All
great.
right.
Thank you.
So where do you want to start? You want to start with this question?
Yeah, we can for sure. The other thing I'll get you thinking about too, I've been hearing a lot about Mow May. I don't know if you guys have covered that, but
don't worry.
Let's talk about that.
We haven't gotten to that yet.
All right.
We're still in recreational mowing in some places here in the Northeast.
Okay. So yeah. So I agree with kind of what you set up there with that picture, the ruler, and aerification sounds like great. It's one of those things that sounds a lot better than it is. But the reality is, especially with the home lawn equipment, you're just not poking enough holes to really affect the soil physical properties. But there's something to be said for just being out there and doing it, right? We talk about that in the golf. You got ice on the greens. I don't know. We don't know what the solution is, but if you go out there and do something, it looks like you tried. So that's what I'll say about aerification. It's a way to increase revenue, form some goodwill with your customers. It makes sense to them. But you want to be prepared for the fact that their lawn probably isn't going to improve that much if it's truly compacted. So for those, the picture of the person you showed with like the best lawn in the neighborhood doing it. Okay, yeah, that's fine.
So the logic is this, Doug.
Yeah,
let's steal the logic from God. Well, it wouldn't look that good if I didn't do it. I do this.
That's right.
Twice a year, and that's why it looks this good. As soon as I don't do it,
it's gonna fall apart.
Yeah.
But the thing that really works is the top dressing the compost. We did that study they showed Rochester and Buffalo, and we were down in Minnesink and White Plains. We did it in Wisconsin here too. It works. The problem with it is it's a ton of labor. You got to find a good source of compost and spread it out on top. And kind of the recommendation that we've settled on now is about 1/4 inch in the spring and 1/4 inch in the fall. Now, the products we were using in the New York study were composted manures, which are loaded with phosphorus. So, that's one of the problems is we want to reduce phosphorus in in turf soils and urban environments. So those are not going to be ways to do that. What we've been finding in Wisconsin is they've used the composted yard waste. They're much, much lower in nutrients, and they provide the same or even better physical property benefits.
Do you need to aerify? Or I think I've heard you say you're just better off just spreading them. Do you need to aerify?
That's right. So in the New York study we had aerification with and without compost. It didn't matter. So the aerification is not what's improving things. It's the compost. So just top dress the compost on if you're really trying to be the most efficient. So yeah, after a couple, 2-3 years of that, that's all you need. It's not like you have to continually do it, but 2-3 years of a 1/4 inch will build up that surface to the point where you can grow pretty healthy grass. So now this study that I ended the study in Wisconsin in 2016. Okay, 6 years ago. I don't have the plots marked out, but just last week I walked out and I can point to the plots that had the compost on them 6 years ago. They're that much better. So I mean, that's it. 3 years of 1/4 inch spring fall, and you basically fixed that soil or improved it for.
Okay, so listen. So here's the angle I'm getting at here. The angle is, okay, it's one thing, the question is, do you need to do it on those lawns that already look really good and don't have an infiltration or soil physical problem? And I'm hearing you say, well, it looks like you're doing something, but you're not getting a lot of benefit. If you do have restricted infiltration, compacted soils, maybe in some areas on a campus, in grounds, large grounds maintenance areas where people are doing things, you can improve the infiltration there. Do you think that there's an argument to be made when you do have compacted soils, that this has an environmental benefit? I know Horgan might have looked at this once before. The role of aerification and fixing that soil and improving infiltration in improving the water quality in the urban environment, even if you're fertilizing that lawn.
Yeah.
So how does soil management relate to improved environmental quality, assuming we're not using the phosphorus loaded stuff?
Yeah. No, it's the most important thing. So the ability of the soil to absorb water is the most important ecosystem service that we're providing. And so your job, if your job is as a turf manager is to do that in an urban environment, that's what you need to do, is how do we get more water into this soil? And so you might have to renovate it. You might have to put in like a artificial sand compost mix to help soak in water. You might be able to do it by top dressing compost, but that's what you got to do, because that's where the environmental impact is. If you get the water from the streets and the driveways and the rooftops, and the soil can't accept it, then it ends up in the streams and the lakes. And even if there's not carrying phosphorus from the fertilizer, it's carrying phosphorus from the sediment in the streets and the tree leaves that are breaking down. So you just got to stop the flow of water. You want the soils to accept the water. And that's tough. And that's why we have so many drainage problems, right? Because the turf is already doing that. And then we're putting more water on it from the high school parking lot or whatever. And then soils are compacted from gym class. So it really is something that has to be actively managed. But understanding that what Frank just said there, that the ability of the soil to absorb water is the #1 environmental benefit that your turf area can provide. That's the way you want to think about it.
That's what I'm trying to get at. And I'm also trying to realize, how much does the way we design these urban environments impact the benefits or they can have? And that brings up the Jordan Cove experiment. Can you talk a little bit about BMPs for urban landscape design a little bit, that then make it easier for us to not spill stuff on the pavement all the time?
Yeah, I think that Jordan Cove, it's an older project. It's been done for a while. I think the website's still up, and they do a really nice job. You can take a tour of all the BMPs they used. And if you look at them, the way I contextualize that one is like, look, we know how to solve the environmental problems that we have. That's not the issue. And that Jordan Cove project proves it to a point. Like they actually improved the environment over doing nothing in some cases by just engineering the environment to accept water. And so it's things like sharing a driveway. There's just reducing impervious area. The impervious area they have, make it pervious. Use porous concrete. Use porous pavers. Rain gardens. Just filter. It's all about the water management. We know how to do it. Why doesn't it happen? Because of money. So it's an economic thing. The houses that they built in that Jordan Cove project that were BMPs cost $50,000 to $100,000 more. And you know, that's money rules everything, right? So people aren't doing it. The regulations aren't there because if you make the regulations to increase the cost of construction, it can be super unpopular and vote you out. So yeah, that's the sad reality is we know how to do this stuff. It's just it takes money. And you're probably thinking if you're, you know, yeah, I got compacted runoff, so I don't have the budget to fix them. I can't replace the soils.
So the other thing I want to throw in before we take any questions, or Carl, if you got a comment, what about that guy with the nice lawn? What about the cost of showing your customers you're doing something and building your revenue like that? Or thinking, you know, doing aerification in areas it's not needed. Number one, you're burning fossil fuels to do it. Number two, how much soil gas goes off? Is this completely crazy, Doug? Is the same rule applied because we're not affecting much of the soil? We probably don't burp off a lot of soil gases. What is your sense of that crazy idea of ecosystem disservice?
Yeah, that's good. I think let's start with the last one. If you poke a hole and you pull a core, some of that carbon, some of that organic matter is going to gas off. But my guess is that you poke the hole, it's going to fill back with roots, and it's probably net zero. So I don't see a big problem with that. But you're right on the fuel use, absolutely. So that's one thing that the turf industry, my student Michael Becken wrote a nice paper about this for the International Turfgrass Conference that shows that, you know, when you convert a cornfield or to grass, you start sequestering carbon into the soil, but you only get about 20, 30 years until you become zero, right? And then all the fuel you're using to maintain it is a carbon cost. So, you know, as turf managers, we got to start thinking about how do we reduce our energy use in maintaining these landscapes. And I think we're seeing that with battery powered stuff that we can charge with renewable energy. But certainly, yeah, if you over managing stuff, you're just wasting fuel if you don't need to do it.
Perfect. Carl, what do you think?
Yeah, the thing I'll add, Doug, and this is actually going to be our tip of the day next week, is the cost or the energy consumption shipping materials, top dressing to a golf course, getting equipment made into a golf course. I think Michael showed that has the highest energy consumption, greenhouse gas consumption compared to energy use on property. So that's another thing. When we're doing things, I think you call it recreationally, Frank.
Recreational mowing.
There's a cost to that as well. There are a couple questions.
Let's get them.
Rich Bradley's got a question on sandy soils, raising CEC values, any kind of compost, specific compost, leaf compost, biosolids, suggestions there to raise.
So using soil amendments, Doug, to improve chemical properties of the soil.
Right. Yeah.
Yeah. Organic matter will do it. Just the way chemical nature of organic matter, it's got a lot of those negative charges. So zeolites, the inorganic amendments, probably not worth the cost. Just go with any organic matter, and that's going to increase that cation exchange capacity and the water holding capacity.
Watch your phosphorus levels, right, yeah. Doug? Part of your rule with organic matter is you're not putting a 1/4 inch of dairy manure biosolid on lawns comfortably. You're saying if you're going to use it, it's got to be a particular kind of compost. And let me bug you on this. Is it consistent? Is you're playing around with yard waste, or you're poking around when you talk about people about this? Do you hear comments about consistency, MSW to MS, municipal waste to municipal waste?
Yeah, I mean, that's a big issue. All the sources are going to be different. And the big suppliers of it are usually pretty good. They're testing it frequently. They got records. So I would say I probably have less issues with the yard waste stuff because there's less like potential for urine and salts like that. But Penn State's got a great compost testing lab. I'm sure there's others out there, but I send my compost when I'm doing research out to Penn State, and they'll tell you if everything's in spec. But you want to make sure that those things are in spec. Yard waste is going to have lower nutrients, which is going to be beneficial for urban environments.
Right. What's the other question?
We're not going to let you go, Doug. You wanted to talk about Mow May, and I sense maybe a controversial opinion on that. we've been talking about bulbs in the lawn. Frank, you showed that the picture of the hyacinths, people letting that grow as long grass, native grass until maybe June. What are your thoughts on No Mow May?
I mean, I love that people are thinking about lawn ecology. That's really cool. I just feel like it's like everything else. You come up with a cool tagline and you think you solve the problem. But I mean, my thought, if mowing was removing all the dandelion heads and all the flowering clover and creeping Charlie, we wouldn't be trying to control them. I mean, those things bloom underneath the canopy in most cases. So like talking about recreational mowing, we'll play on words here. The tagline should be Mow High, May, June, and July, right? Or something like that. Where,
Like that.
where you're allowing those, what we traditionally call weeds, to bloom, and they're pollinators, and you're mowing above it. And so when a dandelion, then after the yellow flower comes up, the white puffball goes way above and you can mow that off. But I don't think that mowing is going to increase pollination at all. I think it's, do you kill your weeds or not? Don't kill your clover. Also, what blooms in May? Great, we're feeding pollinators just in May. That doesn't make any sense. We got to focus on the clover, which blooms June, July, August, September. I think I love that people are talking about it, but I feel like the message of like, let's just not mow in May and that's going to solve the problems is pretty ridiculous. And it's going to create headaches for municipalities and schools that have to come in and deal with it. So
You're gonna need bush hogs.
Yeah.
Bush hog.
Exactly. And it's going to scalp the turf. It's going to create all kinds of problems. I think just mow high, mow sharp blades, 3-4 inches. Don't kill your weeds. Don't call them weeds anymore. Call them, lawn pollinator plants. And we're going to be in a better position.
I got to tell you, the thing is, Doug, you're exactly right about the No Mow May. It's good people are thinking about it. But the concept that relaxed mowing could potentially allow more flowering plants to thrive in lawn settings is going to take time, because what you're saying is, I think what's going to happen the minute you stop mowing, the first thing you're going to see are those lawn weeds that we've selected for the last 50 years for the way we've managed our lawns. And if you want a more diverse lawn planting, and you want to relax your mowing strategically, two things. Well, don't do it when the grass grows the most. Like in November, you see some guys like me who can barely get a beard. And then I got a buddy who's like, flavor saver, eating food out of his beard after a month. So I do think it's important to understand that this is a bad time to do it. But as we think more about servicing pollinators, what your point is, what we'll end with, Carl, here, Doug's point about this, that pollinators want to be there as long as they're there the minute they get here or start doing their thing. They want to be here for the length of your growing season, right? And if all you do is help them in May, I don't see what good, I'm with you on that. I don't see what good that entirely does, using the lawn as a habitat. Thanks, Doug. Good to see you.
Good to see you. Thanks for having me.
A couple of weeks. Looking forward to getting back to Madtown.
Absolutely.
Thanks,
Carl,
everybody.
get us out of here.
Yeah, thanks, everyone. This is episode 10 in the books. Thanks to Doug. We'll post a bunch of these links that you heard about today. Doug just posted a nice link about bee lawns from the University of Minnesota. So check those out in the video below. We'll see you next week.
This has been a production of Cornell University, on the web at cornell.edu.